So you are not audible.
Yeah, now can you hear me?
Yes, sir.
Okay. Yes, sir. So, I sent an email you remember last class we did an antibiotic fermentation, one was that grisofolvin.
Yes,
So, what my suggestion to you all is, just pay attention to my emails. Manasvi, did you see that email?
Yes, sir, I did.
Did it had, really I forgot whether I had put both the antibiotic, vancomycin and grisofolvin or only grisofolvin. Can you just check and tell me? There must be two
Yes, sir,
slides.
I'll just check. I'll just check 1 second.
Yeah, cool.
So there are two PPTs. One is antibiotics fermentation and the other is vancomycin fermentation.
Yeah, so the antibiotic fermentation, once you will open, no, you will find it as that's a grisofolvin. If you all remember, last class we did it right from procurement of the strain to almost recovery in the drum. Little faster, but I think we understood the principle and we did. So, you will have an answer. Now, today, first, before we go into the second part of it, let me tell you. That you might have an questions. There are multiple ways these questions are being asked. From exam point of view, I need to clarify to you all so that you don't get confused while writing. See, if it is upstream production, then I'm now talking on a fermentation and just recapping onto it. But upstream production, then you should draw a fermenter, you should discuss about the media, you should discuss about isolation from the soil. Yeah, and then fermentation time, temperature, probes, which we all talked about, up to the harvest. Yeah, so up to the harvest it is all upstream. And once from that, if you see, remember fermenter design, the last valve, the end of the fermenter, I think, after 7 days, the harvest valve. The moment you open the harvest valve and harvest your fermenter, that simply means now it's a downstream processing. And I've sent a huge notes, a very nice notes on downstream processing. And of course, we have been discussing about column chromatography, extraction, crystallization. I think number of time with multiple examples we discuss. Purpose of just telling you, taking you through this is if anybody feel that no, we don't even recollect. Even if vaguely you recollect, it is fine. Is there anybody who don't even recollect this all things being done? So I'm sure you all are, I think, very clear that this was all done. Okay, my suggestion to the whole class, and Manasvi, you can help people to any student who has difficulty. Please make a folder. All the emails which I'm sending, no, all the class which I have taken, just make a folder so that in exam time you have to just refer to that folder, because all the PPTs and some of the Word file and very few PDFs I'm sending. So this is going to be useful during your exam, just to refer and to understand, and even if you want to make the notes. Yeah. Okay.
Okay, sir.
Okay. Fine. So, today what I'm planning to do is it's in a connection, still in a connection with the fermentation, but little more depth. I think up to now what we have done is very good for your level. And little more I wanted to touch upon is one of the very important from an exam point of view. So I would today take only primary metabolites and secondary metabolites. So let me first tell you before we go on to the PPT. So, primary metabolites and secondary metabolites. Let me start with the secondary metabolite. The antibiotics which you saw, grisofolvin and vancomycin, they are not the topmost important for the cell. Yeah. For a cell, any body cell or anything to grow, what is more important is uh, first initial metabolites, amino acid production, protein production, certain pyruvates and energy related. You must have done TCA cycle. At least you must have heard somewhere, TCA cycle. So TCA cycle intermediates, because the energy ATP comes out of that. So the energy requirement, phosphate based ATP. Anyway, I think you all know about TCA cycle. I'm sure you must have heard somewhere.
Yes.
Good. So, TCA cycle intermediates are very important for the cell. So, they are called as primary metabolites. So, when we start our fermentation and when we put the cell, what it does, it tries to grow. Remember, when we right from the day one, we are talking about when we will be doing the screening, we'll put it into the flask and the cell will multiply. Correct? When the cell multiplies, it forms metabolites which are required for its survival and growth. You understand? So mainly it concentrates on its multiplication and growth, the DNA, RNA, amino acids. So these are called as a primary metabolites. Yeah. And as the cell grows, as the cell mass forms, first day of fermentation, second days of fermentation, as it grows, it start producing, it gets it into, you all know the growth curve. I'll be showing you all on the slide, so don't worry. But if you all know about the growth curve of bacteria, where there is a lag phase, there is a log phase, and there is a stationary phase. Yeah. So there are three phases. So the secondary metabolites are generally produced in the stationary phase. So now we will today, anybody has any question up to now, or even in the older slides, I think before I get it into this, I would like to address those questions.
So I have a question.
Good.
Last class when we were talking about, greasophulmin, you said that the last step is decolorization, right? Which is removal of unwanted color.
Yeah.
If the color remained, let's say decolorization was not performed, would it affect the end product in any way?
Oh, yes, good, very good question. This is the question which even at an very late, big industrial meetings and sometime when we are really working, no, actually in a work life also in an industry, this question comes up. Yeah, so I'll first tell you, yes, it is very important to remove this color, because this color comes from what? These colors come from the impurity. At least you agree that grisofulvin, if you know that grisofulvin is a white color crystal, yeah, then you understand that this color is coming from something else which is absorbing the visible light, and that is why you see a color. Yeah. Nice.
Yes,
Did
sir.
you get that much point? Correct. So now I'll
Yes,
tell you,
sir.
it is very important. See, from color point of view, I'll tell you, if you get certain products, say your toothpaste, correct? If it is supposed to be white, just imagine if it is white, correct? But normally you are getting a white toothpaste regularly. Of course, I know that we are getting colored ones, but let me first take an example of an normal, absolutely white color toothpaste or tooth powder. If it starts getting yellowish, or even like I will say that even dark yellow, I'm sure we all feel that it is spoiled. It is not right thing. Correct? So color removal is very important from acceptance of the product. But that's not the only thing, because grisofulvin is an antibiotic which is to be injected into the human beings, correct? So if you inject an impurity which is in the form of color, it will have its own toxicity, and it can create a uh, real negative effect into the human. Instead of getting cured, they might get into certain other kind of allergies or disease. So it is very important to remove color, even in a food product, even in a pharmaceutical product. So any of the fermentation product, it is very important to give an white color crystals. If it is a white color product, I don't mean that if it is a yellow color product, you give a white color crystals. Yeah. So it is very important. I'll just give, okay, I can give you one big example of Mississippi mud, vancomycin production which I have sent. Though we have not done it in a class, I expect that you will see all the slides, and if you don't understand, you will ask me the questions, yeah, and on my phone or on the class. But I'll give you example of the same vancomycin. The vancomycin was, in an early days, almost early days means I'm talking about it was discovered in 70s, but I'm talking almost up to 90s, 85, 90. It used to come in a color form. There used to be color. And Eli Lilly was one of the world's giant company which tried to remove this color by changing a fermenter with a glass line. Up to now I told you about a metal fermenter, SS, stainless steel fermenter. But they put a glass line inside, and that is how they got a colorless vancomycin. And that is the only company which got then later on approval, because the rest of the people who were making vancomycin which was colored was giving a very severe allergic reaction onto the skin. Vancomycin is an injectable antibiotic used for cardiac or MRSA staphylococcus infections. So that is how it is very, very important to remove the color. Did that I try to elaborate answer very elaborately, so the whole class gets an ask. Every stage in an fermentation purification is very, very important. Though with every stage we lose certain amount of product, but depending on the product cost and the acceptability, we have to see to it that we provide an absolutely acceptable and better than anybody else's product, so that our product will fetch a good cost. Did you got it? The whole class, I think I'm sure this must be a useful question, and try to answer it in more elaborate way. Any other questions? Okay, can you all see the slides now?
Yes, sir.
Okay. So, I will take you through the primary and secondary metabolites. Yeah. And these notes I will send you. Yeah. So primary metabolites are produced during the exponential growth. Just 1 minute back, I explained you, correct? Exponential growth. There are 3 phases of growth. Yeah. So when the organism as soon as it start multiplying, and it is multiplying at a great speed, that's an exponential growth phase. And that is the time organism produces the primary metabolite. And one of the example of primary metabolite is alcohol. Yeah. Not because alcohol they want to drink and get drunk, but alcohol is if you know Tca cycles and multiple cycles, which are energy production and multiple other amino acids and other biochemical pathways, then alcohol is a very important aspect there. And the secondary metabolites are produced during the stationary phase. Now the organism has grown to the extent it has finished off all its nutrients which we have provided. Nutrient is carbon, nitrogen source we have provided in our media, correct? So that's what it is. And yeah. So now secondary metabolites are not essential for growth. You understood, I think we told, because it is produced almost at the end of it, correct? Formation depends on a growth condition, produced as a group of related compounds. They are almost related compounds. Grisofulvin was a secondary metabolite. Vancomycin was a secondary metabolite. They are always produced in a multiple small structural changes, because it's in a chemical pathway where the organism is coming to almost the end of its life cycle. Often the significantly overproduced. Yeah, they secondary metabolites, because they are produced in the end stage. So the organism is not worried about the energy utilization or anything else. So they are produced in a large scale. And they are produced by a spore forming microbe during sporulation, because sporulation is when the nutrients gets depleted, the sporulation starts, correct? So, one thing which I want you all to understand this diagram, because 100% there is going to be a question on explain the primary or secondary metabolite diagrammatically. Yeah, so just concentrate. If you all would have been in a class, it would have been a great, but doesn't matter. Can you all see the two slides A and B?
Yes.
Yes, sir, we can.
Yeah. So, just concentrate right now on A. Yeah. What is it is? Can anybody read? So, I get more confidence that you all are ready. Just if you all have to read this A side of slide, whosoever is just available, please read it. I'm not taking the names. Anybody. Yeah. Okay. No problem. So, I'll read this slide. So it was an A. If you see, it's a primary metabolites written as a title. And if you see x-axis, x-axis is a time. And if you see the y-axis, it is alcohol, sugar, or cell number. See, the cell number of cells itself is an primary metabolite, correct? The number of cells, if you are talking about the yeast cells, then they themselves are a primary metabolites. And that is how, if you now see this diagram, can you see this blue line? In this A diagram, a blue color line.
Yes.
What is happening at a zero time is almost here. I think x-axis and y-axis you all understand. And at a zero time, the sugar, blue color is representing the sugar, that is glucose. Let's take for example. The glucose will be at an highest concentration because that's a starting point. Suppose 5% glucose in a media, Zepax media, which we were talking about. Then it is a highest level. And as the time progresses, the organism will utilize the sugar and see that graph is coming down. Sugar graph is coming down. Yeah. And what will happen when the sugar is coming down, organism is using the sugar, what it will do? Just see the red line. A corresponding red line at a zero time point has to be zero. And because the cell, we have just added very few cells as an initial production. As the sugar is utilized, the red line is increasing. And can you see it is first increasing in exponentially and slowly when it is a time is at the end of the phase, it is becoming a flattening. Now, how many of you have understood this? At least 2-3 people must tell me. Then only I'm going further because otherwise just draw this diagram yourself. And this is what is very, very important diagram. That's why I don't want you to, after defining what is primary metabolite, what is secondary metabolite with the example and this diagram, that itself is sufficient. We'll learn a more detail, but it is very, very important for me that you understand this diagram. Let me ask the name wise. I think you all are not volunteering. Okay. Rupal, are you there? Looks like she's not there. Tanvi, Tanvi Sharma. Okay, you are there, right, Tanvi? Okay, I think there is some distraction in your, that's fine. Shakti, are you there?
Yes, sir. I got it.
So can you just explain me this? I'll put on to this slides again. So can you see the slides now?
Yes, sir.
Can you explain this primary? Once you explain, I think I get confidence that the whole class means most of you, 60% to 80% of you have understood because it's very, very important for you all to understand. It's slightly complicated at this point. It is not that difficult, but slightly complicated. Can please explain me this A graph?
Yes, sir. So if I say something wrong, please.
Oh, it's okay. See, I might be saying so many wrong things even now, in spite of 36 years working in the same
Okay,
field.
sir. So cell, we have like few number of cells because we have added it. So it is not zero. the red line, it represents cells, I think.
Correct,
So we
correct.
have added few cells, so it is not 0, but it is, the number of cells are increasing with time.
Correct.
So that's why the graph is going upwards.
Yes.
And then alcohol production, it's not starting very initially, like from the 0 point of time. It is taking some time,
Yes.
and then the alcohol is produced, and the production is again increasing with time.
Perfect.
And sugar, I think the cells, they are utilizing the sugar, so the sugar is decreasing with time, the amount, I think. Maybe
Yes.
I'm not sure.
Perfect. I think, what you explained is extremely perfect. Now I'm very much satisfied that at least I have come across with at least one or two. So this is what called as a primary metabolite, correct? See, primary metabolites will go up when the carbon source reduces. The nutrients. Sugar is representing the nutrients. So as the nutrients gets depleted, the cell itself is a primary metabolite, so it is increasing. And you very well notice, maybe I would have missed out that the alcohol production will not start at a 0 hour when the certain number of cell will reach. That is why it takes around 1 to whatever hours. Here I have not given the dimension, but it starts only after 16 to 18 hours when significant number of cells are there. So that's very well noticed. That's what I liked it. I would still stay with primary because this is, very favorite question A. And B, if you understand primary and secondary metabolite, it's going to be very, very good for your future. What I'm telling is for your exam point of view, at the same time, in overall your performance. So, can one more person from the class can same diagram can explain in his or her own way?
Sir, can I try or?
Yes, sure. Who
Okay,
is that?
so
Who
this
is
is
that?
Manaswini.
Okay, Manaswini, tell me.
Yeah. So basically the x-axis represents time and the y-axis represents alcohol, sugar, or the cell number. So in the beginning of any kind of growth cycle, so let's say any microbial growth cycle, the sugar levels will be very high because, like you mentioned, we're adding the nutrients. So at that point, let's say like 5% glucose, it'll be quite high. Then once the microbes begin to replicate and grow, so that will be the exponential growth phase as is seen in this graph here. You can see that as the cells increase in number, the sugar levels also go down because as they grow, they utilize more of the carbon source. So when they are growing, as mentioned, during the exponential growth phase, primary metabolites will be produced. So here it's alcohol. So as you can see, as whenever the cells are in the exponential growth phase, alcohol is being produced. And then once they kind of begin to reach the stationary phase, the same happens to the alcohol graph as well, because the primary metabolite is produced only during the exponential growth phase.
Extremely good, extremely good. I'm completely satisfied. I think now I think I'm sure that you all will able to reproduce this very easily. And why I was so much after you all, because one of the MSc class which I was taking, they were finding it difficult to understand. But I'm extremely happy that you all have clearly understood what does the primary metabolites are. You have understood the growth phase here, that its cells are slowly growing, and then they pick up the growth, they become exponential, and then when they become the stationary phase kind of thing, or then they flatten out, even the primary metabolite production will flatten out. Now I think I'm very comfortable, and the whole class just on a very similar principle. But as I told you, secondary metabolites are not that much essential for the cell growth and number. They are required for multiple other work, other thing which organism need, and especially when the organism is getting into stationary phase, they pick up the production. They lyse out, the cells lyse out, the whole energy cycle is no more required. So the concentration goes on to secondary metabolite. And here now you come. See, again, we'll go back to sugar, correct? First, let's understand. Sugar is in the fermentation, x-axis is time. And here the y-axis, just concentrate on penicillin. I'll come back to cells and penicillin. But penicillin will see the last. First, just see the sugar coming down. So as the time goes, the sugar is coming down. Yeah. Now just see the red line. The cells are multiplying. They are multiplying fast. But look at that. They are becoming a flat curve. And not only flat, they slowly start lysing. All the cells. It's like, we all the life in the world will start growing. They will grow exponentially. Then they will become very, very slow. And ultimately it lies out, correct? It disappears. It breaks down. It kills itself. So that is what the cell cycle you can see. And now concentrate on a penicillin production. So you saw, I think one of you very nicely pointed out that alcohol production took place just when the cell numbers are growing, a certain number it reached. See, the penicillin production started so late, almost like, 3 days, 2 days or 3 days. If this is 10 hours or 8 hours, this is almost like 2 days, the penicillin production just started. And actually, if you see, when the cells have reached to the almost peak, almost to the stationary level, it started producing. And the penicillin is then started producing in a very large quantity. And by the time the cells are started lysing, the penicillin production reached to the peak. So these two graph, I'm sure, I think any other than Manaswini and Shakti, anybody else can pick up this graph and explain. I think two more people explaining this graph, and then I think you all can enjoy your day. I'm ready to close the class. I'll be very happy that you have clearly understood. Yeah. Anybody else from the class pick up this graph B and explain? Yogesh or anybody who normally speak. Don't feel shy to speak, yeah. Speak out. It's always nice to speak out. Nehal. क्या हो रहा है? Hello, am I in class? कुछ terminate तो नहीं हो गया? Hello.
Yes, sir, you are audible.
Oh, you all have went to so silent. I thought I got disconnected. Is Devanshi, Nehal, anybody there? They have disappeared or what? ठीक है भाई. Daniel, are you there? Please put on the camera. I doubt that 80% of you are not there probably. Let me take the attendance right away. Thank you. Yeah, Mansi, I know you are there. Tanvi, can you see the diagram, Tanvi? I think Manasi, you can put off your camera, no problem. I know you are there. Tanvi? Oh, she can't hear. Probably she is. Can you see the diagram? Can you explain this diagram? Nihal Joshi, are you there? 80% class hai nahi. See, I have no problem whether you are there or not. Yeah. Okay, Yukta. Can you see the slides, Yukta? Beta? Can you see the slide? I'll
Sir,
put.
right now I can see myself.
Okay, one sec. Can you see the slide now? No?
Yes, sir.
Okay. So good. Just try to understand the B. Just look at the B part of the graph, and you must have heard little bit what I said, and two of your colleague who
Yes, sir.
explained. So please try to explain B, and I'll be happy. Please go ahead, Gupta.
Sir, yes, sir. So the difference between graph A and B, I would like to point out is that in graph A, we saw that the production of primary metabolites starts during the exponential phase, as Manaswini mentioned.
Yes.
But when we see the second graph, in case of second production of secondary metabolites, it occurs almost when the exponential phase ends and the stationary phase starts. So and when the production of cell, I mean the death of cells starts after the stationary phase, the cell lysis occurs, the production of secondary metabolites increases exponentially.
Excellent, excellent. I think I'm confident, but some of you are not answering in the class. So, the person who is teaching, and especially like me, who is not really from academics, he feels that have I been able to go across or not. So this is excellent. I think perfect, and I'm completely confident that the whole class has understood this. And why I'm insisting, you'll come to know when you'll start writing your exam. Yeah, but anyway. So I've given you examples here, and we have now a definition of primary metabolite. We have a secondary metabolite, and I think these three slides at your level are more than sufficient. But just because I would like to give you a full exposure, because this all slides I will be sending, and now little more depth I'm taking after understanding the penicillin production. Yeah. And now I'm taking, there we are talking only about a carbon source, correct? There we were talking about sugar. But here I'm taking a penicillin production in realistic manner. This is a real life picture, that is actual fermentation. So here I put the timings. On an x-axis, you will say 20, 40, 60. These are the hours. And here we'll talk about biomass. Biomass is nothing but a cell number. So don't worry about don't get confused about it, correct? Yeah. So if you see here, the sugar is here, blue color sugar line. The actual sugar which was used during this fermentation of penicillin was lactose. Yeah, the sugar was lactose. Glucose is one kind of sugar, xylose is one kind, as mannitol is one kind of sugar. Similarly, actually lactose was used in the fermentation. Yeah, and that is why you can see that as the time passes, the lactose comes down, and the green line of penicillin is that is antibiotic production is increasing, and the cell numbers you have seen. I'm just adding one, see, because we already talked about a product, we talked about a carbon source. I just wanted to also tell you the nitrogen source, that is ammonia. See, can you see nitrogen feeding and all that? You don't worry about it. That is too depth. But just see at a black color line, and you can see the nitrogen source is that is ammonium nitrate, which is getting depleted and which is being measured using the probe. I think somebody in a class during the fermentation construction has asked me that what are these probes and sensors. So ammonia sensor is one of the very good sensor, very sensitive one. And you can see that as the time passes, the concentration of ammonia is slowly reducing because the cells are utilizing for its growth. The carbon and nitrogen source are used for the growth, and the penicillin production starts when the cell is almost dead. I think I'm sure now. This is only one thing I have added in this graph, that is nitrogen source, because for all life, carbon and nitrogen source are very important. So the first graph and this second graph, if you can draw this second graph, your full marks are secured. If anybody now other way around, if anybody felt that and you didn't understood, this is, it is very same as the previous graph. Don't get confused with this glucose feeding and nitrogen feeding. That is like, we continuously add it into fermentation, so we call it as a feeding. And this is real life graph. So that part is not important for you all, but for you all to understand that ammonia is being reduced, that is nitrogen source is also getting reduced along with the carbon source. That is sufficient. And if you have noticed that we were, if you remember, we were putting 5% of sugar, that is glucose, and that carbon. So at that time I told you, look at that nitrogen source are very low, relatively percentage wise. If when you will see your graphs, you will come. I mean slides, you will come to know. Anybody who want the again the explanation for this slide?
Yes.
Okay, so now you have understood what is primary and secondary metabolites. Now I'll give you more examples because there are multiple times you'll be asked that give examples of, not just an example. So secondary metabolites are often large organic molecules that require a large number of specific enzymatic steps for production. This is another definition for secondary metabolite, and they are like tetracycline is an antibiotic which you all know. That requires at least 72 separate enzymatic step. इतना नहीं, इतना डेप्थ आपको नहीं पता, याद रहेगा तो कोई प्रॉब्लम नहीं. At least you should know that the secondary metabolites require a lot of enzymes, and enzymes are primary metabolite, and that is why and they are multi-step. तो ऑलमोस्ट मल्टीपल एंजाइम्स चाहिए, इसके लिए एंड में बनना चालू होता है. बट इनफ टू नो दैट टेट्रासाइक्लिन इज अनदर सेकेंडरी मेटाबोलाइट. Yeah, I think this first 4 or 5 slides are right now enough. This is the actual fermenter. I wanted you to show. So for primary and secondary metabolites, I think we have almost finished. And now what I want you all to see, this another purpose of this slide set is actually fermenter, because ये आप लोग यदि कॉलेज में आओगे तो मैं दिखाने का ट्राई करूंगा. That puts me into another question. Is anybody coming to college? No? All of you will be online, right?
So
Yes.
most of us will be online.
Yeah. So these are some of the pictures. This is fermenter, another diagram of fermenter, which is exactly the same as what you have seen, except here little more blades are being seen. If you remember, if you just try to recollect, I'll give you 1 minute to recollect the older diagram of fermenter. बहुत same है, absolute the same, except you can see the blades here and impeller के blade लगे हुए हैं, oxygen के bubbles दिखते हैं वैसे. Yeah, so I'll send across these slides. But today's class, I think I'm more than happy that I've come across. Most of you have understood primary and secondary metabolite, understood these two graphs, and if this graph is understood, and one more example of secondary metabolite is tetracycline. Any antibiotic you write, penicillin, vancomycin, grisofulvin, tetracycline, these are all secondary. And primary metabolites will be enzymes like cellulase, amylase, all those will be enzymes, because enzymes are required for breaking down of sugar, correct? So the enzymes will be there. Any amino acids which will be primary metabolites. The components of DNA, ATGC, you must be knowing adenine, thymidine. I think that must be taught. So they will be primary metabolites, because cell को multiply होने के लिए DNA चाहिए, RNA चाहिए, protein चाहिए, enzyme चाहिए, right? So if anybody has any question, please ask me, or in 2 minutes time we'll close this class. I think I'm more than done today, because this was one of the very important topic. I thought it will take much longer, but you all have understood very fast. Thank you. कुछ पूछना है तो पूछ सकते हो.
Sir, in the main graph you showed, the primary metabolite is not mentioned now, but it is there. It will be there.
In the first graph?
Sir, the main one which combines both of the steps.
See, their cell itself is a primary metabolite, correct? And the penicillin production, the cell itself is a primary metabolite. How I'll tell you. It's a set of primary metabolites. Cell itself, cell के अंदर क्या होगा? DNA होगा, RNA होगा, amino acids होंगे, protein होगा. So ये सब जो बनता है वो सारे primary metabolite के example है, वो cell के अंदर है. So that is why there is a cell number I showed you increasing, the second graph where ammonia was coming down.
Okay, sir. Thank you.
Okay.
Sir, I had a question.
Yes, Yukta.
Sir, in the second graph, why the concentration of lactose has decreased? I mean, drastically. Even before the end of exponential phase, I noticed in the second graph.
I think good question. Lactose is less preferred. Glucose is a more preferred source, yeah, and lactose is relatively less preferred. You all must have done lac operon. There is a feedback mechanism is there. लैक ऑपेरॉन सीखे हो आप लोग कहीं जीनोमिक्स एनीवे इतना डिफिकल्ट नहीं करता हूँ आई मेक इट मोर सिंपल see what happens is lactose is first broken down into two sugars and then the one of the sugar is getting utilized. So if I'm measuring only lactose, it drastically comes down. Similarly, I'll give you even easier example. If instead of lactose, if I would have used starch, the starch per se will break down very fast because actually the exponential phase will come from easily utilizable. The TCA cycle, correct? The glucose and glucose 6-phosphate enters into the different chemical cycle, glucose 6-phosphate, fructose 1,6-diphosphate. And that is why the more complex carbon source will drastically come down because they are being broken down into easily utilizable sugar. And once the easily utilizable sugars are there, the cell mass will pick up. Did I answer or it became very complicated?
Yes. No, sir.
Okay,
It's
fine,
clear.
fine. So you understood.
Thank
With two example, starch was not there. Starch में बहुत होता है. Starch फट से टूटना शुरू होता है और फिर एक्चुअली ग्रोथ की सेल ग्रोथ आती है क्योंकि जब ग्लूकोज अवेलेबल होता है तभी सारा एनर्जी मेटाबॉलिज्म शुरू होता है इसके लिए. Anybody? Okay then. Thank you for being here. ठीक है. तो अभी नेक्स्ट क्लास से हम ये फर्मेंटेशन जो मेरा फेवरेट फील्ड है बंद करके वी विल शिफ्ट टू अदर फ्रॉम एग्जाम पॉइंट ऑफ व्यू एंड ओके आई एम श्योर यू ऑल हैव गॉट असाइनमेंट्स एंड असाइनमेंट्स विल बी रेडी. यू आर मूविंग टूवर्ड्स मेकिंग असाइनमेंट. अभी तो काफी दिन है, 10 to 12 more days, but if you have finished earlier you can send me. I will find out how to send. Just now keep it with you, scan copy. Okay then.
Okay, sir.
Thank you, sir.